Solving exponential equations, Part 2. One method we can always use to solve equations is to solve equations graphically. Remember, what you do to solve an equation graphically is you take the first side of the equation and set it equal to y1 in your calculator, and you put the second side of the equation in y2. So if we were to solve 500 e to the negative 0.2x power equals 5, we would type 500 e to the negative 0.2x power in y1 and 5 in y2. We would find where the graphs intersect, because where they intersect is where they are equal. If you're doing it in your calculator, you use the second calculate and choose the intersect function. And sometimes you may just be given the graph itself and you just read the point from the graph. Here, using the calculator, we can see that the x value, where y1 and y2 are equal, is 23.03. If I round this to the nearest hundredth, it would be 23.03. Often, when we get equations that are rather complicated, the graphing method may be the easiest way to solve it. Now, let's take a look at this equation and see if we can solve it by hand. 500 e to the negative 0.2x power equals 5. Because the e has the variable in the exponent, we want to try to get the e part by itself. So the first thing I want to do here is divide by 500. So that gives me e to the negative 0.2x power equals, let's see, 5 divided by 500 is 1 over 100. So I'm going to write that in its decimal form as 0.01. Now, I have e to a power equals 0.01. So to solve this, I can take the natural log on both sides. Remember, I want to choose the natural log here because my base is e. So I have the natural log of e to a power, and that's just going to give me the power. Negative 0.2x equals the natural log of 0.01. So now, to solve for x, I'm just going to divide by negative 0.2. So I should get the same thing that I did doing it graphically. So let me put this stuff in my calculator. I want to do the natural log of 0.01, close the parentheses, and then divide it by negative 0.2. And you see that I do get the same value that I got graphically. Let's look at the next problem here. 6 times 1.3 to the x power minus 4 equals 20. We're going to solve the rest of these equations by hand. You always have the option of doing them in your calculator or checking them in your calculator, but we're going to do this one by hand. So we want to get the part with the exponent in it by itself. So my first step is going to be to add the 4 to both sides. So that gives me 6 times 1.3 raised to the x power equals 24. Now once again, I want this exponent part by itself. So I want to get rid of that 6. because the 6 is being multiplied by 1.3 to the x power, I'll undo the multiplication by dividing. So that's going to give me 1.3 to the x power equals 4. Now, this is my base, 1.3, so I'm going to take the log of base 1.3 on both sides of the equation. Log base 1.3 on both sides of the equation. That gives me these bases the same, so I end up with just an x. And over here, I have the log base 1.3 of 4. So that's going to be, when I use my change of base formula, the log of 4 divided by the log of 1.3. Now this would be considered the exact answer. I could put that in my calculator to get an approximation. Log of 4, close parentheses, divided by log of 1.3, close parentheses. So this answer is about 5.28. Here we have 5 to the x squared power equals 5 to the 2x plus 3 power. This problem's kind of special because we have the same base on both sides of the equation. So if I have 5 to a power equals 5 to a power, I know that these powers have to be equal. So here, I can actually skip the step of taking the log base 5, because doing that is just going to give me the exponents. If I write it out like this, those will cancel each other out, and I'll just get x squared equals 2x plus 3. So you can really just skip that step altogether and just go straight to setting your exponents equal to each other. Now, I need to solve this equation. This is a quadratic equation. So to solve it, I have to set it equal to 0. So I have x squared minus 2x minus 3 equals 0. And then I solve that by factoring. So that'll be x minus 3 times x plus 1 equals 0. Then I use the zero product property to set each factor equal to 0. So x would be 3, or x would be negative 1. Now let's just look at the graph here so you'll see what happens. We might have to play with the window a little bit. 5 raised to the x squared power and 5 raised to the 2x plus 3 power. And you have to put the 2x plus 3 in parentheses. Let me start with a standard window. Zoom 6. There's my first graph. And there's my second graph. Now, I want to see what happens when x is 3 and when x is negative 1. I can see when x is negative 1, I have an intersection there. But I can't really see what's going on out here when x is 3. Let me look at my table. When I go to my table, I can see when x is 1, I'm sorry, not 1, negative 1. When x is negative 1, both of my graphs have a y value of 5. When x is 3, both of my graphs have a y value of 1.95 times 10 to the 6th power. This bumps into scientific notation. So it gets very, very large. But what's important here is that both of these have the same y value. Now, if I were to change my window so I could see that, let's see, 1.95. So let me make this 2. E6. And we should be able to see them intersect right near the top. Yeah, we can see somewhere in here they're going to be intersecting. So we do have 2 points of intersection on this graph. Now, this problem is different because the bases are not the same. So I can't just say that x plus 2 is going to equal 2x because I have different bases. So I'm going to have to proceed with this problem by taking logarithms on both sides. I'm going to try using, or I'm going to use base 3 here. The log base 3 of 3 to the x plus 2 power equals the log base 3 of 4 to the 2x power. Now, what's nice here is that the log base 3 and 3 to a power is going to give me just the power. So I have x plus 2. Here, I can't do that because my bases are different, but I can use my properties of exponents. I'm sorry, properties of logarithms. The properties of logarithms say that this exponent I can pull down in front. So this will be 2x times the log base 3 of 4. Now, if I'm solving an equation, remember I want everything that has x in it on one side and everything that doesn't have x on the other side of the equation. So this has an x in it. This is just 2 times x times some other number. And this has an x in it. So I need to move this x term over here with this one. So I'm going to subtract an x from both sides. That'll leave me with 2 equals. Now I'm going to write this a little different here. I'm going to write this as 2 log base 3 of 4 times x minus x. This, remember, is minus a 1x. Now, both of these have an x in it, so I'm going to factor that x out. This is 2 log base 3 of 4 minus 1. So all that is just a constant. I can put that in my calculator if I want to. 2 log of 4 divided by log of 3. This number is just 2.5237. Then I want to subtract 1 from that. So this is really like 1.5x. So to get the x by itself, I'm going to divide by that number. Now, you need to be careful as you're working these problems out because you don't want to round your values too soon. Here my x is actually equal to 2 divided by 2 log base 3 of 4 minus 1. I can get the approximation to that by doing 2 divided by that number I just found. So this is about 1.31. This would be an exact answer. This would be a rounded answer.